Welcome to the Explainer. Today we're tackling something a little bit different. We're not just going to explain a theory, we're going to try and piece together a blueprint. We're taking ideas from some really cutting-edge thinking to sketch out a theoretical design for one of science fiction's greatest dreams, a device that can actually navigate through time.
So let's just jump right in with the biggest, most audacious question of all. Can we engineer time? I mean, think about it. We're all just passengers, right? Floating down this river at 1 second per second. But what if? What if we could stop being passengers? What if we could actually build a vessel, a machine, to navigate that river, to steer? Okay, so before we can even start talking about building anything, we hit a massive wall. To build a machine that works outside of our normal reality, you first need a completely new set of rules. A new language, really, because our current physics, as amazing as it is, it breaks down at the kind of extremes we need to go to. So the sources we're looking at propose this new mathematical language, and it's called the Unified Number System. The best way to think about it is like a massive operating system upgrade for reality. Our current math is fantastic for building bridges and sending rockets to Mars, but when it runs into something like infinity, it basically just throws its hands up and gives up. This new system, though, it's designed from the ground up to handle different kinds of infinity and numbers that are impossibly small. It lets us finally write the code for what's happening inside a black hole or even at the very first moment of the Big Bang.
And this comparison really shows you what that upgrade gets us. On one hand, you've got classical math, the physics we all know. It's perfect for describing our single, predictable reality. But the second you point it at a singularity, like the center of a black hole, it just breaks. It can't compute. But the unified number system, it's built for those crazy extremes. It can actually model what's going on inside the singularity, and it can even handle the branching realities that quantum mechanics suggests might be out there.
The main takeaway here is that this isn't just some abstract math problem. This new language is a legitimate toolkit for solving some of the biggest puzzles in all of physics. It could even be the key to the famous black hole information paradox. That cosmic mystery about whether information is truly deleted forever when it falls into a black hole.
All right, so we've got our new rulebook, our new physics. Now we can finally start talking about the fun stuff, the hardware. And for a machine like this, well, you're going to need one heck of an engine, a power source made from the most exotic, most powerful stuff we can possibly imagine.
And that power source has a name, an antimatter Bose-Einstein condensate, or AMBEC for short. Just try to picture this. You take antimatter, the mirror image of regular matter, the stuff that explodes on contact, and you chill it down, way down, to the coldest temperature physically possible in the universe. So cold that all the individual antimatter atoms, they stop being individuals, they lose their identity and merge into one single giant quantum superatom. That is the core of our engine.
And the theoretical recipe for how you'd actually make one is it's wild. It sounds like something straight out of a movie. But every single step here is based on real cutting-edge physics. First, you make your antihydrogen. Then you have to trap it with incredibly powerful magnetic fields so it doesn't touch anything. After that, you use lasers to literally slow the atoms down, which is a super clever way of making them colder. And if you get them cold enough, they hit what's called quantum coherence, and boof, they all collapse into that single ultra-powerful alembic state. So we have our new math, and we have our crazy quantum engine. But an engine is pretty useless if you don't have a map, right? Where are we even going? Well, for that, we have to look at a pretty radical view of reality itself. This is our navigational chart.
Let's start by throwing out a metaphor we all use. We always think of time as a single river, just flowing in one direction, always moving forward. But the kind of physics we're talking about today, it suggests that picture is way, way too simple. Instead, I want you to imagine time as this vast branching landscape. This is basically the many worlds interpretation of quantum mechanics. The idea is that every single time a quantum event has more than one possible outcome, the entire universe splits. A whole new timeline branches off for every single possibility. This creates this immense, explorable multiverse, and that is our map.
So, just how big is this landscape? Well, one of the sources we looked at makes a pretty stunning claim. It says that for all the math to work out, for cause and effect to still make sense, and for the three families of particles we see in our universe to exist, we don't just need one dimension of time, we need three. 3 dimensions of time.
Okay, this is it. This is the moment we've been building up to. We have the new language, we have the quantum engine, we have the map of the multiverse. It's time to put it all together and actually look at the blueprint for this thing, a temporal navigation device, or TND. So here it is, the whole shebang. 4 main parts. First, you've got the Ambac core we just talked about. That's the engine, providing all the raw power. Second, something called the cognitive converter. You can think of this as the ultimate mind-machine interface. It literally reads your thoughts about where you want to go and turns them into coordinates. Third is the entropic shunt. This is your propulsion. It basically makes the reality right around the device slippery for a moment, letting it just slide from one timeline to another. And finally, the chronos stabilizer. This is your anchor. It locks you into your new timeline and, maybe most importantly, stops paradoxes from ripping everything apart.
Now look, this blueprint is obviously deeply theoretical, but just exploring the idea, it forces us to ask some really profound questions. So let's shift gears from the technical how to the absolutely staggering what if. What would our world even look like if this technology became real? Honestly, the implications are just mind-bending. Humanity would go from being passive observers of the universe to being active participants. We'd become, as one source puts it, co-constructors of reality. This is what's called an ontological technology. It's a big word, but it means something really simple and profound. It wouldn't just change what we can do, it would fundamentally change what we are. Everything we take for granted, cause and effect, our own identities, our entire ethical system, all of it would have to be torn down and rebuilt from scratch. And that kind of leaves us with one final, really provocative thought. If every choice we make creates a new branch of reality, and we suddenly get the power to travel between those branches, what does that do to our sense of responsibility? Are we only responsible for our own timeline? Or are we now responsible for all the other timelines we could have created or could now visit? It's a question that goes way beyond physics, and it really gets to the heart of what it means to make a choice at all.